Okay, just a few words on logarithms then and what they are. Basically, logarithms, I've written a log here, log to base a, this is the base number here, and you can unwrap a logarithm and write it in its indicial form. So you can either write a problem in logarithmic form, or you can write the corresponding indicial form equation. So to unwrap a log, basically all you do is this a comes down and hits the y in the air. So you end up with x equals a to the y. So you can go from this to that and vice versa. So they're equivalent to one another. So let's just review that again. If you have a to the y equals x, which we're used to with indices, you can write the equivalent logarithmic form by just swinging this chap down here, and he comes underneath to be the log, and then the y drops down to ground level. And you can write y equals log a of x. Or you can do the reverse, you can swing the a up and swing the a down and hit the y in the air, and then x equals a to the y. Sometimes we want to do problems in logarithmic form, sometimes we prefer to use indicial form, depending often on the size of the numbers involved and whatever's most convenient to use. So now we know what a logarithm is, we can work out some logs, can't we? So if we said log 10 of 100 equals 2, say, if I wrote that in indicial equals a question mark, I've just given you the answer here, then to find out what that would be, you'd unwrap the log. So the 10 swings down, hits that in the air. And what power of 10 is 100? So that's what, and we know it's 10 squared, don't we? So we could put 2 in here and 2 there. So that's what a logarithm is then. It's the power you need to raise 10 to get to the value. So what power do we need to raise 10 to get to 100? Well, we need to raise it to a power 2. So if we look at our calculator then, I've put it in here, log 10 is this button here on this calculator. There's also other logs here. This is the natural logarithm, which we'll talk about in due course on the next section. Here's the log to any base. So log 2 of 8 then, for example, what would that be? So if we wrote it down here, log 2 of 8, question mark. Let's write it in indicial form. Swing the 2 down, hit the question mark in the air. And that would equal, so 2 to the question mark needs to equal 8. What power of 2 equals 8? Well, we know it's 3. So that would be 3. So let's just check that on the calculator then. Equals 3. So that's what logarithms are. And you can go from logs to indices and indices to logs and find values of logs as well. So as we pointed out here, you can use this logarithm to get logs to any base. Now there's rules for logs, which I'll just show you. And they're very similar to the rules that we used for indices. So I'm just going to write down the rules so we're all happy to use the rules. Remember with indices it was times you add, wasn't it? Well, the same law pertains in logarithms, equivalency wise. So log of a of xy times you add the logarithms. So times you add, just as we had with indices. Divide, remember what we said before? You minus top take bottom. So divide you minus top take away the bottom. So there's the other rule. Now the other power you times, there's no correspondence for that, but basically log a of x to the y, it's not difficult to show using these properties that what happens here, this rule is the y jumps down to be to ground level, y log a of x. So that's another rule for logs, which is easy to remember, because basically all that happens is this chappy in the air just swings down and goes here. And then if you want to bring it back up, it swings up to be the power. So that's the rules. Now what's the log of 1 then? That's the other thing we can worry about. So if we had log base a of 1, say any base logarithm, equals question mark, well then you'd need to ask the equivalent question. 1 equals a to what power, isn't it? A swings up, hits this in the air. A to what power is 1? Anything to the power 0 is 1. And that tells us that that logarithm then, log a of 1, is 0. Okay, if we check that on the calculator, then we could do log 10 of 1. Should get 0, shouldn't we? And if we do log, say, of base 3 of the number, say, 1, we're doing log of 1, is 0 again. Okay, good. So that's a little overview of logs and how we use them. Times you add, divide you minus, top, take, bottom, and the power rule is this, log a of 1 is 0. Most times this is all the rules that we need to worry about.